Hey there, Mr. Weaver here, and this is the Geometry Unit, Lesson 5, Distance on the Coordinate Plane. After this lesson, you need to be able to find the distance between 2 points on a coordinate plane using the Pythagorean Theorem. Let's learn. Find the distance on a coordinate plane. Going through this, we're essentially going to use the Pythagorean Theorem, so let's look at the steps we need to figure out how far apart 2 points are on the coordinate grid. So first, we're going to plot our points if they're not already, and then we're going to use those points to draw a right triangle. The segment between the 2 points is going to be the hypotenuse. So here we can see we have our hypotenuse is what's connecting those 2 points. And we made a right triangle out of it by following the grid. Then, once we've made a right triangle, we're going to count how long the legs are. So this leg here has 1, 2, 3 units tall, and this leg here is 4 units wide. Now, to find our missing side length, we just use the Pythagorean Theorem, which we learned back in lesson 3. So a squared plus b squared equals c squared. If I plug in 3 for a, 4 for b, I get 9 plus 16, which is 25. Taking the square root of that, the square root of 25 is 5. And again, we only use the positive value, so c must be 5. Example 1. Find the distance on the coordinate plane. So find the distance c between 3, 0, and 7, negative 5 on the coordinate plane. Round to the nearest tenth. So first, let's graph these 2 points so we can start to make our triangle. Here's 3, 0. Here is 7, negative 5. Now, we're going to connect them together to make our hypotenuse. To finish out drawing the triangle, we need to make the legs, so we're going to follow the grid. Here I drew the triangle there, but I also could have drawn my legs over here, and it still would make a right triangle, and we would still get the same correct answer. So now that we've made a triangle, we need to count how long the legs are. So on the bottom, it is 4 units. And the one on the left side here is 5 units tall. So the legs are going to be 4 and 5. Now that I know that the legs are 4 and 5, let's use the Pythagorean Theorem. So a squared plus b squared equals c squared. A is 4, b is 5. So 16 plus 25 is equal to 41. Then I need to take the square root. So the square root of 41 is 6.4. So the length, or the distance between those 2 points, was 6.4 units. Check your understanding. Find the distance c between these 2 points on the coordinate plane. Round to the nearest tenth. Use the grid on the previous problem if you need a place to plot your numbers. Pause the video now and complete the check. Check your answer. You should have found that the distance between these points is about 7.2 units. To get there, first, negative 3, negative 4 is down here. 1, 2 is up here. So if I'm going to make my right triangle, it would look sort of like this. Or maybe you drew the legs down here. Either way, this is 6 units tall and 4 units wide. 6 times 6 is 36. 4 times 4 is 16. That would be equal to c squared. So 36 plus 16 is 52. Then the square root of 52 to get c would be rounded to 7.2. Let's apply this to maps. The map shows 2 walking trails in a park. Both paths end at the picnic area, located at point C, which is 6, 1. Trail A starts at point A of negative 6, 6, and trail B starts at point B, which is at negative 10, 11. If each unit on the map represents half a mile, how many miles longer is trail B than trail A? So first, write down what are we trying to do here? What is the task? Pause the video now and complete this part. Hopefully you wrote something along the lines of find the distance of the trails and see how many miles longer B is compared to A. Now, how can we approach this task? What strategies can we use? Pause the video again and write down your thoughts. For this, we need to find the distance of those trails. So we should probably be using the Pythagorean theorem. Now let's figure out our solution. Pause the video and see if you can figure it out before I go through it. Let's go through how to figure this out. So trail A, first I need to make a right triangle. For trail A, the triangle we can make would be 5 units tall and 12 units wide. For trail B, it would be 12 units tall and 16 units wide. Now to find those missing trail distances, I'm going to use the Pythagorean theorem. So 5 squared plus 12 squared is going to be equal to c squared. That's our trail A. 5 to the second power is 25. 12 to the second power, 12 times 12 is 144. Together, that's 169. Then to solve for c, I need to take the square root. So the square root of 169 is 13. So c must be equal to 13. I'm going to call this a different letter just because I don't want to use the same thing, but I'm just going to still do the same thing. So 12 to the second power plus 16 to the second power is equal to that length of the trail squared. 12 times 12 is 144. 16 times 16 is 256. Added together, we get 400. And then taking the square root of that, D, or the length of trail B, must be 20. So trail A is 13, trail B is 20. So how much longer? You might be tempted to say, well, if A was 13 and B was 20, that it should be 7 miles longer. But remember, each unit represents half of a mile. So if it was 7 miles on here and each unit is half, then we have to take half of that. So half of 7 is 3.5. So 3.5 miles, that is how much longer B is compared to A. And then how can we know that our solution is reasonable? There are a few different things we can do to help say that things are reasonable. One, we know that the grid only goes from -10 to 6. So the fact that we're in the low numbers and not something crazy like 35 would be a good start. We didn't get a negative number. That would be bad if we came up with the fact that trail A was longer than trail B. Maybe we could take this and somehow swing it down and realize that it would come to about there. We can see it's just a little bit farther. 3.5 is not too much. So different visual strategies we can use, along with some other things that you might have come up with. Check your understanding. Read through the situation and use the map to determine how many miles longer trail A is compared to trail B. Remember, each unit on the map is a half of a mile, which you can factor in at the end. Pause the video now and complete the check. Check your answer. You should have said that A is 2 miles longer than B. If we make our triangles, so I'm going to do it this way and up here. They were nice enough this time to put it on the grid for us. This one is 5 long. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 units. Again, make sure you're counting the spaces, not the lines. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If I do the Pythagorean theorem, 5 squared plus 12 squared is 169, so this must be 13. 8 squared plus 15 squared would tell us A is 17. So they are right now a 4 mile difference. But remember, half a mile, half of 4 is 2.